So we'll be posting the recordings in the lecture recordings channel, which Dylan, you should have permission to put things there, but nobody but teachers can.
Okay.
Everybody is welcome to call or put reaction emojis on anything posted in any channel. I left that ability up. That way you can keep track of which ones you read if you want to, or whatever else.
Gotcha.
And I did all the work for this week yesterday, and it took about 8 hours. Today's lecture is going to be moving pretty quick. We'll have a Q&A at the end. So if you've got any questions, be sure to write them down. Mike is going to be joining us as an assistant. He works with me, but he was interested in learning a little more about C#, which is the language we'll be focusing on for this course. So like I said, Tabby, save any notes or questions for the end. That's when we're going to do our questions and answers section, because we're going to be moving pretty quick through this.
Okay.
Part of why we're recording it is so that if you guys do have questions and you remember that it was referenced in the lecture, you can go watch the recording and get any of the information we covered. Okay.
Mm-hmm.
I'm also going to include the lecture notes that I wrote for this week in the channel so that you guys can have like a transcript version of it as well.
Hot. Okay.
So the first part of the things we're going to be covering this week is data variables. There's a lot of different types of data variables, but the important way to think about them is they represent structures of how we communicate. So in C#, because it's different in every language, but in C#, you have a number of basic variables that come pre-installed in your environment. The first one's a bool. That's going to be a true-false value. It's going to be a 0 or a 1. That's always going to be represented by 1 byte. A byte is dependent based on what kind of computer you're on. 32 or 64 is the standards nowadays. So on either computer for a bool, it's going to be 1 byte, but that byte is on a 32-bit computer is 4 bits, and on a 64-bit computer is twice that, so it's 8-bit. A char stands for character. That's going to be letters, numbers, special characters, where we don't really care what the value is. We just need to know what the character is for display purposes. There's also things called breakout characters. That's where you're going to get like your enter keys and your spaces and your tabs. A character in C# is typed between 2 single quotes. And a string is a collection of characters, like a sentence or a name. That's going to be any characters, though. It's not. It doesn't have to make any sense. So it can be like a password or a hash table. Those are represented by double quotes on either side of it. Not all languages have a string. In fact, most of the lower level languages like C and C++ don't have a default string built in. But those are our non-number types that we're going to worry about for now. There's some extra ones. These are the built-in ones that we want to care about. Our numbers get a little more complicated. So we have an int. That's going to be a whole number, positive or negative. There is an unsigned version of an int, and that means it can't be negative. It's always positive. But an integer, which is what int stands for, is a whole number, and I think it can be it's fairly large, but it's stored in a 4-byte section. So that's where you're going to get, if you want it to just be the top of a fraction, or if you're just counting the number of something, you're going to use an int. There is a smaller version of an int that's called a short. It's half of an int. You don't see them used a lot, but if you're trying to streamline your program, it's a pretty good choice to use a short. And just like the int, short and long both have an unsigned version, which means that they can be strictly positive. but you can't directly put a signed integer into an unsigned integer because that has to do with bit storage, which we're not going to cover this week. When we head into the more precise numbers, we've got decimal, which is going to be one of your most precise numbers that you can get default in C#. That's going to be up to 29 digits, and it stays very specific. So it's not going to be rounding or anything like that. It's going to give you a literal answer when you use a decimal. A lot of financial programs will use this because accuracy is really important, down to the penny. Obviously, you can go way further than a penny with decimal. One of the other places you'll see decimal used is in timestamp. So if you need to count all the way down to nanoseconds, you're going to use a decimal. A float is a floating point decimal. This is more of a flexible number. It's where you see the calculators giving you things that aren't quite numbers anymore. You got like a 3e to the power of 14 or whatever. This is going to be a lot less accurate. This is going to do some rounding, but a lot of the math functions in C# require a float type. And the reason I say float type is a double is considered a float. It's just twice the storage space float. Everything sounding good so far?
Yep.
Did I miss anything, Dylan?
I don't think so.
Okay.
Do you have to put an
So-
F under, after a double? I don't remember that being a thing. At the end?
There's a couple of ways you can initialize a double. The F isn't required for a double. It is required for a float.
Okay.
But there's some other ways you can do it as well. Just putting it up there for ease.
Yeah.
The reason types are so important in C# is C# is considered a strictly typed language, which means anytime you make anything new, you are required to tell the program what type that object is going to be, because everything is objects in C#. The other types of objects that we'll see but probably won't use directly, we've got those unsigned numbers I mentioned. There is the object type, which is an overarching type that allows you to kind of store almost anything, but you can get some severe data loss if you go that high up. And then a dynamic type, which is something that's a lot more flexible. You probably won't see it until you have to deal with large structure. So we can ignore dynamic for now, but know that it's there. Our next section of focus this week is going to be classes. So a lot of the structure in C# is programmer-defined objects. That's what a class is. Typically, you want a class to represent a single object. In our example today, we're going to be using coffee. We're going to be running a shop. And I've already written some back infrastructure, but we're going to go through and fill in the rest. Having things pared down to a single object representation helps you to keep things cleaner. We'll go over kind of the structure that you need to focus on for clean code, so to speak, later down this and next week. But one of the big focuses is making sure that an object, one, hides what it's doing from other objects, and two, only has control over the things that it needs to access. So a class has a name. That's the only thing it has to have, other than the fact that C# gives it a constructor by default. But you don't have to define it. But a class can have its own data variables and properties, as well as methods. If you don't set up the constructor, it's going to give you a blank one, but you can allocate a default constructor so that you can overwrite some of the methods or some of the functions going on inside that method. And you do that by creating a method without a return type and giving it the same name as the class. Methods are things that the class can do. So you want methods to be individual things. You don't want them to be large overarching functions. So you're not going to want to have a car object that just has a drive method. You're going to want it to have a turn method and an accelerate method and a braking method. You want to break them down so that you can control them separately. And that way, if you have to change anything in any one of those, you don't have to go through and change it in all of your code. You just have to change it in the one section. But methods have return types. Return types are what is passed out of the method. We've all done the basic stuff with me, but those data variables that we talked about just up above and that you use all over the place are returned by methods. So in the example I use here, string is declared in our method declaration, which is what the whole top of a method is called. And the string is what's going to be passed back to whatever is calling that method. So the way you return is really simple. You just have a return statement in the method. You want to try to keep it to just one return statement per method. So there's some logical workarounds you might have to do in order to do that. But having one return statement keeps it nice and clean. You only got to change things in one place. That's going to be a lot of the focus, because the more code you write, the more bugs you write. But if you don't want to return anything, it's still technically returning an object. And we'll get into that more when we touch into lower level languages, but we'll need to declare that it's returning void. The things that are passed into methods are called parameters. Each one has to be defined in that declaration as well. So we've got our return type here, and then in the parentheses following the name of the method, we're going to say the type and then give a name to the parameter that we're going to use inside the method. So in our boil method here, when it's called outside, they're going to give us an int, and we're going to use it inside the method by calling heat. That's going to allow users to adjust information inside the class or adjust what comes out of the class in return statements. There's a lot of what you can do is focused on parameters, but the rule of thumb for parameters is if you have more than 3, you probably have too many. So you need to filter it back, figure out a way to break down that method so that it doesn't need so many. Everything good so far? Anybody totally lost?
I'm okay.
You good?
Mhm.
Dylan, do you feel like I've missed anything yet?
No, I think you're doing pretty good so far.
Okay, I'm trying to cruise through this so we can get to the programming side of things, and then we're going to talk about the assignment.
Yeah.
So classes can also have variables defined in them. Those are our data variables we talked at the top. These are just defined in the class, but outside of methods, and allow you to have something that you can use throughout the whole class that stays, it's not constant, but it's something that they can all access and change if they need to, but it stays the same across your method. There's something similar for entire programs called a global variable. Typically bad programming practice to use a global variable. Most times when you're using a global variable, you're going to see it as a global constant, which is a variable that doesn't change at all. It can't be changed. This is just going over that. Properties are very special types of variables. A property is in C#. This is very specific to C#, but a property is a variable in a class that comes with its own method. Those methods are always a getter and a setter. And you can see this is kind of how they're declared. These methods help to control accessibility in your class while still providing protection to those variables. And the protection is really important for one of the pillars. We want to hide the data from other sections so that we don't have any crosstalk happening that can cause cascading errors. The different accessibility levels are public, private, internal, protected. And there's additional versions of internal You can have a protected or a private internal variable. But private is going to mean that it can only be accessed from inside the class. Whereas internal means it can only be accessed within the scope that it's declared in. So if you declare an internal variable inside a method, you can't use it anywhere else except for the scope it's defined in inside your method. And by default, that's kind of how things will work, but there's some exceptions. A protected variable is something that can be used by family. So anything that, if you have an object or a class that is inheriting from a parent object, that parent object can have, doesn't require to have access to those protected variables. The same thing applies to if you have a parent object, that child can have access to protected values inside the parent. This means we can have crosstalk between family classes without letting that loose on the whole program. We're going to talk a lot more about inheritance and stuff next week. So don't worry too much about the family talk yet. We'll get into that next week. For the last portion of my lecture notes, we're going to be talking about object-oriented programming fundamentals, which for clean design, you want your code to stick to 4 pillars, which are pretty basic to almost every software engineer. But the fundamentals of object-oriented programming are abstraction, which is wanting to hide those bits away because you want to keep the distracting stuff out of the code. In my example here, I say, if your friend is asking you for a cup of coffee, they don't want to have to tell you, hey, add water to the kettle, boil the water, add grounds to the machine, place a clean cup in the machine. They just want to tell you, hey, get me a coffee. So we want to hide away all those steps in its own method. Encapsulation is kind of the other side of that. Encapsulation is where we put those hidden steps. So we're going to hide those away in a method or in a class, depending on how big it is. And those are the only 2 we're going to focus on for this week. The other ones kind of touch on that family stuff that we'll be talking about next week. If we've got our program, which our example is, we're going to be running a tea shop. So we don't want to go through and write all our code right here in main, because we don't want to have to add how long everything's going to boil for and how to check for flavor, all sorts of stuff. We're going to want to define objects that encapsulate that information and abstract it from our program. That way, when we're coming in, it's just going to read as get coffee rather than all the steps we don't want to see. So in our example today, and your guys' assignment is going to be based on car dealership. You guys are going to be building an inventory, but I've broken it out into 5 assignments that will be covering that. But for my lecture, I didn't want to go over the homework, so we're doing T, but it's going to be similar concept. So these are my predefined variables. You can ask for user input for these. I've done this just for simplicity, but you see I've got a bool, a char, string, int, short, long, decimal, float, and double. I'm not going to require you to use all of these variables in any of your assignments. I want you guys to pick the ones that are best, but I wanted to use all of them so that we can show them being used in our program. Does anybody have any questions on the lecture notes stuff that we went over? I'm going to take the silence as a no. Dylan, do you feel like I've missed anything?
I don't think so. I think it's going good so far.
What? Just again, not the numbers, but the like the name.
As I go through things, I'm going to point at what we're looking at. Okay. So, like I said, everything in C# is an object. So even our main method, our main program, is a class. And you can run this without having it in a class, but for the sake of Visual Studios, it likes to spell out those top level statements for you so that you can see each piece that's actually going on in the background. So any method inside a class is declared with, this one's optional. By default, it's not considered static, but you can also declare public beforehand. And there's some intricacies to what things default to in C#, but that's very specific to C#. So the first thing we're going to do is we're going to want to create the objects that we've used to encapsulate code. When you're creating an object in C#, you're always going to use this new function, and you're going to call that default constructor that we talked about, which shares the same name as the type. Our default constructor for shop passes in a name. Our shop's name is going to be C#. And then we wanted to add some things to our shop. So we've got a T and a tool. And you see that I've got T and tool up here. We're going to briefly touch on inheritance in this lecture because that's going to be one of the things we move into next week, but we're not going to define any of it in this lecture. So moving forward, our T has several methods: set flavor, set caffeine, and set temperature. Those allow us to control things inside the T object without having to put all the steps out here. That's showing our abstraction. And the method, or the classes here, are showing our encapsulation. Our shop also has methods, and these ones, as you can tell, none of these ones return anything. So they're all set to void, which you can see by hovering over them. If you see any red squigglies, this means that something's wrong with your code here. So in this case, it's saying, hey, we don't know what kettle is. So we want to come over here to kettle, and oh yeah, I haven't defined it. So the first thing you do is you add class kettle, and I am inheriting from tool in this case. So tool is over here, and I haven't put anything in tool either. But in your parent object, all you want to define is the things that will be common between all your child objects. So we want them to have a name. We want to tell if they're on. We need to have a default constructor that sets the name and makes sure it's off. And we want to be able to toggle the power. The last thing we need to do is check if it's on, which allows us to access this private bool, which by default it's private in a class, without breaking the abstraction and encapsulation we have with our tool class. So now that we've got those, kettle is red here. Where we want to define kettle, it says, hey, you need to have a name. So we have to add our base function, and this is saying, hey, the kettle constructor is actually going to be just the same as our tool constructor. And now it's not mad, and if we go back to our program, this isn't mad anymore either. Still good? Everybody's clear so far? Okay. During this section, if anybody has any questions, just interrupt me. I just wanted to make sure I got through the material before our time was up because I've got a pretty jammed schedule today. While our shop is open, we want to do things that happen in the shop. So we're going to be making sales, and we're going to be ordering drinks and that sort of thing while the shop is open. So we're using that bool as a condition for our while loop. So while it's open, we're going to do things in here. There's a couple of different types of loops. There's for loops, while loops, and do while loops. There's also for each loops, but they're just a special variation of for loops. We should touch on all of them except for do while loops in this code. But a do while loop is the same as a while loop, except it makes sure that it'll run the code inside the scope, which our scope is what's between two curly brackets. It'll make sure that it runs that code at least once. So in this case, if we changed this to false, then our while loop would never run. Okay, and I'm just going to add this down at the bottom. This is saying so that we pause our shop after each order, and then we want to clear the screen so we can get ready for the next customer. Okay, so in operations of our shop, we're going to need to take in user orders. So we've all gone over console write line. That's where we're writing out to the console. So console read line is reading what the user has put on the console, which I know I've walked Devin through that, but I don't think I've walked either of the other students through that. So our read line has a return value of a string, and that question mark after the string just means it's a nullable string, which means we do have to check whether it's null, but in our case, we're going to assume that the user puts something in.
Null just means it's empty, basically.
Yes. Good catch. Null just means it's empty. Forgot Alora can't hear what's going on.
Yeah, how to make this great catch, I guess.
So here we're checking our input. So we are saying, hey, if our input is equal to n, then let's set the shop is open to false and continue, which means it'll jump clear to the end here and try to do the loop again. And in that case, it'll fail and drop out of the loop. This is obviously not fantastic programming here, because they could insert no or nothing or anything they want, and it will only check for if they insert a lowercase n. Here I'm just cleaning up the console, and I'm saying, hey, here's our menu, and printing out the menu. Show menu is a method in our shop class, and all it does is come through, and for each drink on the menu, it's going to add that drink and show its price. But as you can see, it does not return anything at all because it's just printing out directly to the console. Next, we want to get another user input. In this case, we're going to be asking for their drink. We can use the same input variable as we used above. It's actually going to empty out that variable automatically in C#. Does not do that in all languages. Important to keep in mind. But we're going to read that drink option into the input. And then we're going to create a null drink, just an empty drink object, so that we can add something to the orders list that we're creating in shop, because shop has a list of orders and a list of drinks on the menu. All right, our shop needs to check then if that drink is on the menu. So we're going to say, hey, is what the user asked for on the menu. This actually returns a bool. So it's saying, hey, if this is true. But it also has something called an out variable, which is passing out our drink that we passed in by reference, but it's linking it, in this case, to the drink that's on the menu. Because even if we create two separate drink objects that are both called the same thing and have the same variables inside them, they'll count as separate objects. So when we're doing any code, remember that when you've defined an object, it checks if those objects are equal based on memory storage, not based on what's inside the object. Does that make sense? So if it's on the menu, we're going to say, hey, good choice. Otherwise, we're going to say that's not on our menu. Did you say something, Tabby?
No, I was just realizing I was muted.
Yep. Choose muted. All right, so now we need to get the order assembled for our shop. So in this case, this is bad programming because not every item on the menu is going to guaranteed be tea, because we can pass in any drink, which tea is a child of drink, but we'll be touching on families more next week. So if we're looking at drink as a tea, we want to get the flavor of that tea. And tea flavor is just a string. So we want to say, hey, is that equal? If you notice, 1 equal sign is assigning it, 2 equal signs is checking. That's saying, hey, is this equal to t? And if it is, we're going to say our empty t object is now equal to a new t object with the name of input, because it says that's going to be the name, and the volume is going to be our cup size that we defined up above. Then when we're done doing that, even though t is a t variable and drink is a drink variable, we can set drink equal to t because t inherits from drink. So since it's a child of drink, they can count as the same object. Nice. Like an advanced PowerPoint presentation. So now we're going to check if t is null. We're checking, hey, did it get assigned in here? If it did get assigned, we're going to say, hey, how much milk would you like to add, and read that in. So when we add our milk using our t class, we're going to need to, what did I do? We're going to need to check that they did not insert an n, saying, hey, I don't want any t. And if they didn't, then we're going to create milk, because you can only create, or you can only use variables inside the scope they're defined. So if we defined this milk here, then we couldn't use it here because it's only defined in this scope. So we have to define it outside of that scope, and then here we give it a value. So we're going to try to parse that input. We're going to try to change this string to a number. And if that fails, we're going to say, hey, that's not a number. I would like you guys to try to use error catching in your assignments this week, but they're not going to mean that you absolutely fail the assignment if you don't have them. So we adjust the milk inside t before we assign it to drink. Drink isn't going to know anything about the milk because the milk is strictly on our t object, which this is our property, and we talked about that in our lecture notes. So it comes with its own methods. That way, when we call it like this, it knows what to do with that. So if we've made it through this whole section here, and we've decided, yes, they've ordered a valid drink, here's the drink we want them to have, then we want to check, yep, we did make it through a drink, let's order that drink. We're going to add it to the orders part of our shop using our add or order drink, which just calls orders add. And if they didn't end up getting a drink, we're going to say no drink ordered. Then we're going to call our make drinks shop factory method. factory method is something that takes care of assembling new objects. So in our shop, we have our make drinks, and it's going to say, hey, for each drink in order, but it's going to be using what's called an iterator. So it's going to say, while I, which is equal to 0, is less than the number of orders, do this stuff, and then increment I by 1. Does that make sense for everybody? Plus plus does not mean 1, but in this context, because I is an int, it's going to increment it by 1 value that I can increment by, which means 1 in this.
Okay.
So that would be the same thing as saying I plus 1. And there's 2 ways you can do plus plus. You can have it after or before. If you have it before, that means it's going to add that to I immediately. If you have it set to after, that means it's going to wait to do everything else in the scope, and then it's going to increment. In our for loop, we have some errors, and it says, hey, kettle doesn't have anything that says get volume. So we got to go back to our kettle, and we're going to add a get volume method, because our liquid volume is a private class or private variable again, so we can't directly access it. So we want to just get that variable out here. Not out here. Where did we have it? In here. So that we can get access to how much is in the kettle without directly looking in the pot. So we're going to say if the volume inside the kettle is greater than this current order's volume, how much we need to pour, then hey, let's do the pouring of our drink. So we're going to get the serve temperature needed for our drink. We're going to calculate the time we want to boil it for. And then we're going to say, hey, check if the kettle's on. If the kettle is off, because this bang, this exclamation point, which is called a bang, is not. So we go, hey, is it on? And if it says no, then we're going to say, well, if it's not on, then do this, toggle the power. So now that we've made sure that it's on, we can call that kettle boil method. And there's no boil method in kettle right now. So we got to go. And we got to add our boil method, which apparently is the last one. We're going to just get rid of those for now. And our boil method is just going to take in a parameter of double heat and an int of time that it's going to take to boil. So it goes, hey, if it's on, let's say it's warming up, and we're going to add heat to the temp and then wait for it to heat up. If it's not on, we're going to say, hey, that kettle's not on. So if we hadn't toggled it on in our make drinks method, then it would just say, hey, that kettle's not on. So after we boil that water, it's going to come back here and it's going to print out, hey, we finished making order I. So in our case, order 0. But it's going to get the name of that drink specifically. And then it's going to sell the drink, which adds money. Selling our drink is going to check if it's on the menu, check for the price, remove it from the orders list, and then add the money from the sale to the balance of the shop. And I'm going to turn off the kettle after this. We'll, for the sake of time, not do that. I want to. So if we come back out here, now that we've made the drinks, we need to, and sold them to the customer, we need to make sure that we close shop after the shop is set off. So if you notice, I didn't actually use these other methods in here, but I wanted to provide them in case later I wanted to come in and add extensibility to our kettle to allow us to fill it with liquid or allow us to pour more liquid out. So in our program, we're going to say, okay, now it's closed. Let's print out the earnings today. So now we've gone through what I planned to show you guys, and we're in the last 15 minutes. I was a little slower than I hoped to be, but last 15 minutes is supposed to be open up for questions, and then we're going to start going over the assignment. So does anybody have any questions about the lecture material? No questions? Okay.
Not about the lecture material, no.
So, and I'm going to send the first assignment in our assignment section of the Discord. But the goal of our first assignment is to reinforce just the data types, the variable types that we showed at the very beginning of the lecture. So we're breaking up the lecture this week into 3 assignments that are going to build on each other. In this assignment, I want you guys to define these variables, and I've given you examples of what could be inputted so that you guys can choose what you think would be the most appropriate type for that variable. Initialize them with whatever you want, it doesn't matter. But do know that as clean as you write this is going to only help you in the next assignments, because assignment 1 sets you up for the basics of assignment 2, which you get to use assignment 1's parts for. So assignment 1 through 5 are all going to be building towards a completed car inventory system, including sales and stuff, similar to the shop that I just showed. But in assignment 1, you're just going to define these variables. You're going to print those variables out to the console, and then we're going to do some basic calculations on those variables and display the updated information showing, hey, we know how to update specific variables, and we know how to use the console. So our focus is showing that we know which variables to choose, showing that we know how to edit variables and calculate using variables, and then we just want to make sure you guys know how to compile and run your program. Compile in Visual Studios, which I showed you all Visual Studios for our tool we use. Compiling happens automatically when you hit the run button. So that should be taken care of for you. But if it fails to compile, it will throw an error for you, and there will be errors at the bottom of your Visual Studios in this error list. If you're having any difficulties figuring out what's wrong using your error list and reading your description and where it is in the file and project, you can actually come in here, and before you run, you can just drop in a breakpoint, which will stop your program. Come on, why isn't it clicking? There we go. It will stop your program at whatever line you drop this breakpoint in on. So if we run this right now, it's going to run from program, and it's going to come down and hit initialize shop, and it's going to say, okay, our shop is going to have a name of C shop. And it's going to start going through these and assigning them and getting ready to open shop. So now you can see that our name variable is C shop for the whole class. Once it's compiled, I recommend you guys put a folder in your computer somewhere where you can keep these assignments. I've set up folder structure for our boot camp as a whole that includes our C# 101 class, and then which week we're on, and then broken down into the assignments and lecture. You don't have to do that, just a recommendation, but I would like you guys to when you get your code done, you're going to come in here, right click here, and you'll see open folder in File Explorer. And that's going to show you everything you made for your program. You're going to go out one folder. It's actually two folders, I lied. Out two folders, right click on that one. Sorry, a jet going overhead. And you're going to compress to zip file. You might need to download 7-zip if you don't have it. But I want you guys to send me compressed zip folders so that you're not just sending me raw code, because that can be pretty big. And you can send that to me through email or over Discord. I've left the homework help up. I encourage you guys to use that so that everybody can learn from questions other people ask. But if you've got a question that you don't want everyone else to see, feel free to reach out to myself. I don't speak for Dylan, but Dylan is knowledgeable as well.
Yeah, you can reach out to me too.
What?
He
said yes.
Yeah.
You can reach out to him as well.
Yeah.
Yeah, Alora sitting next to me cannot hear you. So,
Okay.
before we wrap up, is there any other questions about assignment 1?
Nope.
The plan for this assignment is for you guys to take today and tomorrow to get it done, and I will be assigning assignment 2 for the week in 3 days. So not today and tomorrow, but the day after. Sure.
Do you want to show
That
them
is
like maybe
okay.
what an error looks like in the window?
Sure. So if we come in here and let's say we remove boil, because we know that's going to cause an error, right? And we save that. We don't see any squiggly lines in our program. But when we click this play button, it's going to go, hey, there's some build error. You can continue with the last successful build, which will run your working program. But typically you want to hit no, and it'll pop up this error message. It'll say what kind of error it was, the description of the error, what project the error is in, what file the error is in, and what line has the error. So we know, oh, it's in the shop file on line 111. So if we go to shop file line 111, we're going to see, oh, hey, look, there's our red squiggly saying that there's no definition for boil in kettle. And if we come and we fix that, then it will actually update and remove that from our errors list. Anybody have any questions?
Not that I want to admit to.
We're all beginners here. Well, all the students are beginners here, and nobody's going to judge you for any of the questions you ask. I'm just trying to rush because ideally this whole boot camp is going to be between 10 and 15 weeks. And by the end of 10 to 15 weeks, I'd like you guys to all be competent programmers. But if you move slower than that, I'm still willing to help you guys out. So